see it there, you could start, right?
Good afternoon and welcome to the University of Trinidad and Tobago, the Design and Manufacturing Engineering Unit. So I would like to welcome everyone this afternoon to our webinar entitled The Potential for Robotics in Culture and Sport. And we have a distinguished panel joining us today, and I'm quite pleased to have everyone here. So firstly, before we get into the webinar series, I would like to introduce our panel. So starting at the top there, we have Mr. Shivanan Maharaj, and he has been a music educator and entertainer in the field of Indian classical music for the past 25 years. So Mr. Maharaj has taught Indian classical music and ethnomusicology at the University of Trinidad and Tobago's Academy for the Performing Arts as a senior instructor, and he's currently a music lecturer at the Department of Creative and Festival Arts at the University of the West Indies, St. Augustine. Furthermore, he is the recipient of the Hummingbird Gold Medal in 2013 for music education and plays several instruments, including the tabla, harmonium, violin, steel pan, and the sarangi. So Mr. Maharaj has been teaching the art of tabla playing for over 20 years and has given many lectures and demonstrations on tabla playing, not only at our local universities, but also at the universities of New Delhi, Baroda, and Punjab in India. Next, to his left, we have Dr. Kelvin Lautan. So Dr. Lautan was a research fellow in the Center of Automotive Engineering at the University of Surrey. Dr. Lautan specializes in vehicle dynamics and is currently responsible for the development of a semi-active vehicle suspension controller. He obtained his Doctor of Philosophy in Mechatronics from the University of Trinidad and Tobago, where he also lectured part-time for 10 years in the Department of Design and Manufacturing. Next to Dr. Lautan, we have Dr. Jorel Bisnath. So Dr. Bisnath is an assistant professor in design and manufacturing at the University of Trinidad and Tobago. He has been an active researcher for over 10 years and he holds his PhD in manufacturing engineering. He was part of the team that is working on developing the Tabla playing robot, and his research interests are in mechatronics and robotics. And next to Dr. Bisnath, we have Mr. Ronnie Bikramdas. So Mr. Bikramdas is currently pursuing his PhD in developing an intelligent cricket bowling machine using artificial intelligence technology. He also has a master's in innovative design and entrepreneurship from the University of Trinidad and Tobago, where he does his research and lecture in the Department of Design and Manufacturing. Mr. Bikramdas was part of the team that won the Prime Minister's Awards for Innovation and Invention in 2004 and placed third in 2007. Mr. Bikramdas is also a level 2 cricket coach and a cricket commentator. And I am Aaron Amarali, a senior instructor in Design and Manufacturing Engineering, and I will be the moderator for this afternoon's webinar. So to kick off things before we actually get into the panel discussion, what we would like to do is to show 2 video presentations. And in the video presentations, we will show a very short video on robotics and culture, and then we'll show a second video on robotics and sports. And once these are over, we will then return to the panel and we will have some questions, some very lively discussions, and then of course we will be taking your questions. So feel free to the live audience that has joined us. We thank you for your participation. Feel free to post your comments or questions such that the panel will be able to view it and answer accordingly. So now we have a look at the short presentations.
Hi, my name is Joel Bisnath, and thank you for joining us today on our webinar on the potential of robotics in sport and culture. The term robot often causes us to think of industrial machines that belong in a factory, but the International Federation of Robotics estimates that there are currently close to 5 million robots being used for entertainment, and this figure is projected to increase by 10% each year. As this field of research continues to develop, many areas that were seen as reserved for human expression or performance are now being exposed to the influence of robotics. A question must therefore be asked: what is the scope for robotics in these traditional non-technological areas, such as cultural expression and sports? This brings us to the robotics research taking place at UTT in the Design and Manufacturing Unit. The project that we will be looking at today is Tumru, the Tabla playing robot. This robot has been developed by a research team headed by Professor Prakash Prasad, Mr. Shivanan Maraj, Mr. Ronnie Bikramdas, and myself. It forms part of the research that is being done in the application of robots in entertainment, music, and sports. Tumru is being developed to have the same capabilities as an expert tabla player, the purpose being to accompany an artist both for live performance and practice. Tumru is what is called a biomimicking robot. This means that it tries to replicate the motions of a human. In this instance, the fingers of the robot are used just like a human to strike the drum and produce sound. This creates an authentic tabla sound without the need for electronic tone generation. It also allows an artist to visually look at the hands to get a sense of timing. A framework was created within which all of the various styles or rhythms, along with their variations, can be programmed or taught to the robot. This structure also includes tiais and moharas, which are flourishes or breaks within the rhythm. This lets the singer use the library of rhythms to select one that matches the mood of the song that they will be performing. The singer is further able to configure the accompaniment to include flourishes where they would like and adjust the speed or tempo. Research is also currently underway on the use of Tumru as a teaching aid within the classroom to help the instructor demonstrate the hand placement and finger movements. Thus far, the robot has successfully been incorporated in tabla classes both locally and internationally. The following is a short sample of the capabilities of the robot.
We learn it faster, right? Ready? Listen and look.
Welcome to this video presentation of the cricket bowling machine with an arm and hand developed at the University of Trinidad and Tobago Design and Manufacturing Systems Unit. The rationale behind this project stems from the fact that the batsmen find it difficult to follow the ball as it is hidden for a fraction of a second as the ball is shot out of the traditional bowling machine. Hence, the batsmen change their stance and setup to accommodate these machines. Since looking at the ball as it leaves the bowler's hand is the main visual cue for the batsman to determine line, length, and bounce of the ball, a team of researchers from the University of Trinidad and Tobago developed a bowling machine with an arm and hand to deliver the ball, which would solve the problem outlined for the batsman. The machine was designed and built by Dr. Kelvin Lawton Jr. It has a spring actuation system that rotates the arm and delivers the ball. The testing and analysis of the bowling machine was done by Mr. Ronnie Bikramdas. The project supervisor is Professor Prakash Prasad. Now, we take a look at some clips of the bowling machine as it is being operated. There we see a slow motion of the bowling machine. Here we see the bowling machine bowling full deliveries at the stumps at 80 miles per hour. Again, another full-length delivery at 80 miles per hour and a side view. Now, we look at some video clips of the testing of the machine using the pitch vision equipment. A front view of the machine, and there we see a side view of the ball hitting the sensor mat of the pitch vision equipment. Now we take a look at some clips of the bowling machine coming up against some batsmen. Let's see how the batsmen will fare. Firstly, we look at some full-length deliveries to the batsmen. Some of the batsmen handled the deliveries well, while some of them had some problems. Again, full-length deliveries from the machine. Now we look at some good length deliveries as this ball is delivered beating the outside edge of the bat. A wonderful delivery. Again, the good length deliveries giving the batsman lots of problems. The bounce and pace of the machine is really good. again the batsman having problems with the good length deliveries. Now we look at some short deliveries from the bowling machine. Again, it's the bounce and pace of the machine is giving the batsman lots of problems. And that brings an end to this video clip of this bowling machine.
Thank you very much for those videos as presented by Mr. Vikramdas and Dr. Bisnath. So now we would like to get into our panel discussion. So good afternoon, gentlemen.
Good afternoon.
And welcome. So for the general public then, if you were to ask a simple question, what is a robot or what is robotics? Dr. Bisnath?
We are accustomed in popular culture with people saying like Terminator on TV or these fancy robots that are able to walk around and interact as a human would. They have all the behaviors of a human. But a robot is a very simple device. It's actually a mechanical device that can be programmed to have some means of sensing and input and be able to display a preordained behavior. So robots are a general term, but they can be very specific, such as an ATM machine, for instance, that you interact with every day. That could be an example of robotics that the average person will interact with.
And what would you say then are some of the limitations of a robot?
Well, in terms of limitations, of course, you may program a robot to do specific tasks, but it can only do those tasks. It cannot make decisions that is outside the scope of what it's supposed to do. So we see, for example, even if you want to go to the point of movies, for example, where iRobot, that particular movie where those were even proposed as advanced robots, but they still couldn't make the decisions as it should in terms of saving our life, for example. So everything is bounded between logic and rules that man programs. So that is, for me, that is the main limitation that we have.
They generally only do what you program them to do. So you can't expect that you make a robot and it displays a lot of unprecedented behavior. Usually whatever specific task you design it for, that's the behavior you're going to get coming out of a robot.
Okay, very good. Mr. Vikramdas?
Yeah. Just to add to what these guys were saying, is that it is limited, right? A robot is limited to what the human wants it to do as such. So you program it, you want it to play an instrument, it will play that instrument. So you can't have a robot that will be doing multiple tasks. Okay. It's going to be a bit difficult. And as Dr. Lautan mentioned, it's going into the realm of AI, where eventually the robots would actually be doing things on their own. Okay. They would learn what needs to be done and do it without human interactions.
All right, very good. And in keeping then with the topic of the webinar, potential for robotics in sports and culture, Mr. Maharaj, how then can robots be incorporated into culture?
Yes, well, I would like to first of all say that when it comes to culture, the whole idea of robotics being part of culture is something that is phenomenal. It's a novel idea nowadays, especially in terms of the robot that we are going to be looking at, which is tomorrow, that has been created by the team at the mechatronics team, and it continues to evolve into really important and very promising features for the future. I want to say that it has a very important place in culture, especially with the drumming aspect of music. That is a world by itself, and it has a lot of potential to be able to infuse a lot of elements of development in our artists and upcoming artists in the country.
Okay, very good. And if we ask the same question, then how could robots be incorporated into the sporting area?
Well, at the moment, robotics, they have been used in terms of football. We have the Robo Cup, which is a football tournament that we actually have robots actually playing the game of football, scoring as the case may be. So, and there's also robotics in wrestling. They're actually in Japan, I believe it is. There are miniature robots that's built for wrestling. They actually wrestle against each other and stuff like that. There are robots that are being used for skiing as well. Okay, so robotics, yes, in sports it's there, and I think it is getting more and more prominent.
Good. So back to Mr. Maharaj, you were talking about robots in the culture and using them for music and training aids. So could you tell us a little bit then about how these robots are able to be used as the training aids and to reproduce the sounds and some of the technical specifications then that the robot must possess in order to be used as a training aid in the classroom?
Yes, actually, the robot, the Tabla plane robot Tumru, is a robot that is able to be programmed. As we say in music, there's a term or a concept called tal, which is just a rhythmical cycle of beats. It can be a cycle of 6 beats, it may be a cycle of 12 beats, a cycle of 16 beats, whatever it is needed for that particular performance. But the thing about it is that this robot is able to handle that type of programming. And not only the exact or the foundation beats or the tal, as we would say, it's also able to reproduce variation. So it can add quite a lot of quality to the performance overall in music.
Good. And in terms of for sporting, what would be the technical specifications that a robot should have then in order to be used as a training aid? And we have Dr. Lautan again, who worked on the cricket bowling machine.
So in terms of the specific to the cricket bowling machine, one of the things we have identified is that it should be able to represent a human being as much as possible in order to provide the visual clues and the visual feedback for the batsman in this case. And in this particular machine or this particular robot, we have designed the machine such that the width of the machine, the height, and as you saw in the video, there's an arm and a hand. All these are proportioned or exactly as that of the average fast bowler. So when the batsman is batting, from his perspective, he would see something visual that represents the shape or form and size of a human bowler. So that, for me, is the main critical aspect that a sports robot should have, that it should replicate as much as possible the human aspect of the particular sport.
Agreed. Yes, Dr. Listener?
Can I jump in?
Sure.
That point that Dr. Lautan touched on is very important for performance and culture as well. Because when we go to see a performance taking place, it's not just the audio that we're going for. People don't go to concerts because they can sit at home and listen to a recording.
Yes.
When they go to a concert, it's about the emotion that the artist is able to convey. And that emotion comes across through their movements and their styles that they introduce during the performance. So by having these visual cues, it's a lot easier for human artists to collaborate with robots. And that is really the distinction with robots in music and electronically generated music. You have a lot of this visual feedback that the average person is able to look at and able to pick up things like timing and emotion from. And I'm sure Samaraj will agree with that in a big way.
Yeah.
Very much. Very much so, because like for example, I've been able to interact with different classes of students who were like novel students of Tabla. They just joined because they were interested in playing this instrument. But now, having seen that the instrument is being played by a robot, the impact itself has has generated quite a lot of hype, as it were, in their interest towards the instrument. And that's because when I talk to them afterwards, they would respond that it's actually looking like a human being. The shape is there, the finger movements is there, and they know it's something that is of a technological nature. So it's very much impacting upon the younger generation.
Actually, as we are talking, we have a question. So in terms of culture, the viewer is asking, in terms of culture, you have the animatronic characters that are used for classical folklores and for shows and movies. Could robots be used in place of this?
I mean, definitely you can have robotics coming in when you want to have the future. So right now, cutting edge in the movie industry and entertainment might be CGI characters, and there are even musicians in places like Japan and Korea where they are not physical people. You have these computer-generated persons, avatars that are able to perform, and they have fans following them, all of these things. So we could get to the point where we have robotic actors or even robotic characters that have personality built in. So it won't just be the mechanical representation, they will actually be able to exist out in the real world and interact with fans, all of these types of things that come with it. Yeah?
And welcome, Mr. Bekandas, in terms of the sporting robot you spoke about. Does this robot have the capability to have different levels based on the skill of the sportsman? Is that adjustable?
Yes, it is. It's as was mentioned earlier. It's programmable, so you can program to at different levels as such. Actually, in the Robo Cup League, there's the actual robot that is human-like with legs and arms, and that actually move. You actually kick the ball, and there's also a different level where it's not an actual humanoid robot, but it's a robot with a base that with wheels and actually has a cup that actually collects the ball and shoots it out as a goal. So they are different levels in terms of the robotics in sport as well.
And in terms of the acceptability of testing, what was the response in testing this robot, let's say for example the bowling machine, against an actual cricketer? What was the acceptability of it, and what was the feel like from the person facing a robot as opposed to an actual human being?
Well, in the testing that was done on this the bowling machine, we actually allow batsmen to face the machine,
Right.
and then they give their feedback. And actually, I asked them to compare this machine with the traditional wheel machine that they normally use, and they actually find it was a lot better in terms of visual aid. As was mentioned earlier, the hand is the main cue for the ball, right? For batsmen to see the ball.
Right.
So with respect to that, they were able to see the ball better. They were able to react in a manner in which that, in terms of setup, the batsman, in terms of their setup, their stance, and all these things, they were able to do it as if they were in an actual game.
Right.
And testing, it was shown that we actually compared it with balls being bowled outside the off stump to batsmen. With a survey that was done by Mr. Anish Kulkarni in India. And his study showed that 73% of the balls bowled in T20 cricket in 2009, from June to November, a total of I think it's 4,800 balls was bowled. 72% of those balls were bowled in that corridor. But with this machine that we built, that Dr. Lawton mentioned, when we did a similar test, the accuracy was 92.3%. Right? And if you look at the pitch map, with respect to balls bowling over, it was very consistent. It was within less than half a meter of each other.
Okay, good. Thank you, Mr. Bekandas. And Mr. Maraj, we saw as part of the video earlier that there's actually a degree in tabla playing in Baroda. And we saw that the students were looking at a video of Tamu while playing. How did they react then to taking classes from that robot, from Tamu?
Yes. Actually, this was a really interesting experience because they were totally amazed by the fact that there was actually this robot being created, that has been created, and was able to play, elements of their degree program, where they were able to play the basic foundation beat patterns, as it were, and it was also followed by other, as it is called in music, other variations, and they were able to, synchronize, as it were, with the robot after some amount of practice that was done, so that it had quite a lot of merit, and their lecturers also were very, very amazed that something of this nature has been created and actually exists, and they have they have extended their interest to to link with us, as it were, to be able to see what else can happen, where their students can move forward and be enhanced through the use of the robot. Yeah.
So then, if you ask a general question, what then would be the major difficulties in developing robotics and bringing products to market in Trinidad and Tobago? What would you say some of our major challenges in developing these products?
So I think the major challenge right now would be the manpower, the people to actually sit down and actually do the work, because it's very, very technical, and we need to be at that level in terms of engineering, mathematics, physics, computer science, especially now where robots are not complete anymore by itself. You need the AI aspect of it. And that's what Mr. Beckmandas is working on right now to complement the actual bowling machine you saw in the video. So I think the major challenge right now is the manpower and I would want to say the drive towards robotics, because we have seen a trend in the world where the world has fallen out of love with robotics. Just like in the 70s and 80s where the world fell out of love with space race and space travel. I think we need to get back that motivation to understand that robots are mechanical devices and it's separate from app building.
Any other challenges from
Well, when it comes to robotics and humans, there are a whole host of considerations that need to be really thought of to ensure that you have a successful device. So part of the work that we did when we were developing the Tabla robot is user acceptance testing. So we had to look at the social perception of this robot. How do players view the robots just by the appearance alone? So we have things like the uncanny valley. That's where when you get closer to a human appearance, it actually becomes more distasteful the closer you become until you actually get it perfectly right. So we have a lot of small technical difficulties that the average person might not think about when they view these representations in popular culture. But when it comes to the actual technology and doing the calculations and the design that Dr. Lowton was referring to, you have that hard engineering side of things, and then you also have the designer's perspective, the industrial designer's perspective, and the human perspective, because somebody has to use the device at the end of the day and be comfortable interacting with it. Yeah?
Thank you, Dr. Snart. So, following on that then, would you say that there are ethical issues involved with robotics? Because there is the public perception that robots will replace or displace humans. So, as I say, as a spin-off of what you're talking about, what's the panel's view then on the ethical issues when it comes to robotics?
I don't think you could get into this field and not be faced with that question.
Yep.
Because at some level, you're going to get the response that this robot is going to replace me. I'm a musician, I'm a performer, this robot is coming to replace me. You even have a lot of industries that are under threat. So like long-haul drivers, for instance, people that drive trucks, with the advent of automated vehicles, this entire industry might become automated, and we'll have a lot of unemployed persons or untrained persons that need to be retrained. So with robotics, there will always be that challenge where you have a disruptive technology coming into this space. But there's also opportunity that comes with this challenge. So, for instance, social media didn't exist 10 years ago. And now that it is here, the way that we deliver messages has changed, newscasting has changed, but there's additional opportunity in this space. So with robotics in performance, just like with electronic music, right? When EDM came on the stage, first of all, people didn't view it as real music. But with robotics, it might have the same initial view, but as it develops and people see how it can fit and coexist with what is there, I'm sure that more novel ways of expression will arise out of this.
Yeah,
That's the way in there.
That's the way in there. I mean, also, it wouldn't be an overnight change.
Of course not.
Right? So as I spoke about trucks and truck drivers and autonomous vehicles, you still need a driver behind the wheel for safety reasons. We cannot be at that level within this generation, I believe, where we'll have a purely autonomous vehicle on the road. So it will not be an overnight transition where one day you wake up and you don't have a job. Exactly. So,
Anyone else would like to comment? Yes.
I would also like to agree and add to what Dr. Bismarck just mentioned, in the fact that the opportunity side of what is there to be accessed is huge. Of course, on the other side, there is some amount of challenge and threat in terms of job loss, etc. But when we look at the other side, on the opportunity part of it, Like for example, when it comes to music education, let's say for example, now we can think in terms of how many more players we can generate to go out into the society, because they have such a heightened interest when it comes to learning instruments and new techniques, new teaching strategies, etc. That is very much attached to this new robot that we have on the horizon, as it were. So that what we can be faced with is actually the advantage of having more personalities to be, feeding into the society when it comes to joining like jazz music bands, when it comes to joining classical music, folk music, Caribbean music, world music, etc. So I'm seeing that aspect of it, having a huge advantage from that point of view. Exactly.
To add a bit to the awareness. Once people is aware of the benefits that robots can bring in terms of, let's say, culture, sports, whatever aspect, I think that will help break down that ethics barrier and such. So it's all about people being aware of these robots. It's not to take your job, it's not to take over as such, but to assist, to help in whatever duties or areas that it may be there for.
Good.
I mean,
Yes.
like for instance, if we have a artist performing in one country, why can't we have a robotic representation of that artist in satellite stations across the world, reproducing the same performance on the stage? In Trinidad, we have a big carnival culture, but with our culture, we've had our developments, we have innovations, but why can't we incorporate robotics into our costume making or king and queen of the band designs? These are big areas, big potential areas for improvement. The adding of animatronics, more visualization. The expressionism is a tool for expressionism and for persons to really represent their creations. Just think of it as another outlet for creativity rather than a threat to creativity.
So then, that, how do you see the accuracy of robot programming impacting culture and sport?
Actually, I see that part of it is can have a huge advantage when it comes to culture, because there's a term in the rhythm world of music. The term is lyre, but it actually translates into speed. And if it is that we can be able to produce artists for whatever genre of music that we are talking about, but they can be in control of speeds for varying degrees for their instrument. Like, for example, somebody can probably be on a tabla, or they can be on some other type of drum or membranophone as we know it to be. We can actually have they're being equipped with the correct level of producing speed or having speed control, which is a huge deal in the music industry, because a lot of them tend to fluctuate. Sometimes after a while they are not trained properly, they tend to drop in speeds, and that affects the level of the performance. Some people, because of excitement, they actually speed up when it is not really needed, and so on. So with the addition of the training with the robot, which is something that is not going to fluctuate, it is going to actually train them in that direction of having proper speed control.
On that point, we have a question, and the viewer is saying that there are other programs like Vocaloids and so on that can replicate a person's voice with speech patterns, and it's enough to imitate somebody singing. Could such a program be incorporated then in a tablet playing robot?
Very much. Actually, I think that discussion has started to take place, because actually when someone sits in a classroom to teach this particular instrument, they are supposed to actually recite what is the phrase pattern and then demonstrate and then ask the student to follow likewise. So that speech aspect of it is definitely something that can be looked at.
Exactly. Yeah. With robotics, you find, with people in general, you find that they personalize a lot of the things that they interact with. The average person puts a name for their car, and this car is an inanimate object. Yeah. So with robots, there is always a tendency to have some type of human characteristics added to it. So things like being able to speak and interact at that level will add personality to these devices and help with the acceptance and to put people at ease when they interact for the first time.
Therefore, in the future, Another viewer is asking, are we going to see or experience Tumru playing Indian classical musical instruments other than the tabla?
We have a lot of research in musical robotics. In train, I mean, Professor Prakash Prasad, who is the genesis of this entire research group, who has pushed all of us into this field, he has a dream of creating an Indian orchestra, a robotic Indian orchestra, actually a robotic Trinidadian orchestra, because we of course would like to incorporate the steel pan into this as well. Right? We'll have tassa drums, we'll have tabla, we'll have the steel pan, and it'll be a full Trinidadian orchestra represented by robots that we could probably have across the world touring or at our embassies.
And what would it take then, Dr. Bisnath or the panel to achieve that?
A lot more research, yes.
Remember we had
Yes.
the pan playing robot conceptualized,
Yes.
and we did simulations, conceptual simulations of it, and we were able to achieve motion between the nodes based on the available motors we had at the time, and that was when that was presented to the conference, and everyone knows the steel pan, but a robot that can play the steel pan is a very impressive thing. So yeah, it's getting there in terms of the research team.
And if I am to fill the spotlight on Mr. Bikram, that's a little bit then. Are there any plans to further the bowling machine that it can automatically switch between the different bowling types?
Yes, definitely. As Dr. Lawton mentioned, we are taking this bowling machine a step further, where we are applying AI technology in terms of the bowling machine will actually learn the batsman pattern in terms of his movement and position of the hand, the legs, and will be able to say, okay, the batsman has an error, and we would be able to correct the batsman.
Right.
So what it will do will run through a set of strategies and say, okay, the batsman has his foot a bit too far from the delivery. So it will start to work the batsman outside and off stump, hold the deliveries a little closer to him and start going wider in order for the batsman's foot to go closer to the ball. That's exactly what a coach will do.
Right.
But with this machine now, it will actually do it without the batsman knowing.
Okay.
So that's the advantage. So the batsman would think he's playing normal or on drives or off drives, but he's actually being taught by this machine.
Very good. So now that's on technique, right? And I know we're talking about robotic research and culture and sport. On the other side of sports now, could robots be used for rehabilitation of sporting injuries then? So we talk about technique and skill. What about somebody who has an injury and they have to do rehabilitative work? Would robotics be able to assist in that area?
Well, in that case, again, is the repetition or the repetitive nature of the robot in this case. So, as mentioned with the Tabla robot, students would watch the fingers in motion and learn from the repetition how to play a specific card, as you would say, right? Similarly, in terms of rehabilitation, if it is you need to, match your swing and your speed and the properties of your delivery, the bowling machine could be programmed such that to continuously provide, well, this is the benefit of the bowling machine, by the way, is the repetitive nature of it. You can get the same ball, the same speed every single time. So with that in mind, someone who needs to be rehabilitated, they could look at the machine, start off slow, and work their way up to like how it was before them, before the particular injury.
Anything, Mr. Maraj, you would like to add in terms of on the aspect of culture?
Yes, I would like to mention that the whole idea of having this robot playing this particular instrument known as the tabla is something huge and something that has a lot of vision behind it. Because the reason I'm saying that is, when we look at music, the tabla, yes, is an instrument, just like a flute would be an instrument, a guitar, a sitar, violin, whatever have you, right? All of these are instruments. However, when someone is playing the sitar, the tabla has to be there. When somebody is playing the violin, the tabla is there to accompany again. So the tabla is not just an instrument to be played, in the scenario of one of these instruments. The tabla must be there as the rhythmical accompaniment all throughout classical music. So it's something that is it's always present no matter what is the other instrument. The tabla must be there to also provide accompaniment. So it's something that is very unique. It's not that every time you're seeing tabla that all the other instruments are there, but every time you're seeing the other instruments, the tabla must be there. So it's something that is really worthy of enhancing in our society.
So to pick up on that point, enhancing, do you think it will ever make it better?
In terms of the quality of the playing of the tabla, yes, very much, because you know that is a process. It takes some amount of time and mindset and proper guidance in terms of the classroom environment to be able to better oneself. But yes, very much it's achievable, and especially with the manner in which this robot has been able to be programmed with all these various intricate lessons that it would. It also has online, possibilities as well.
Yes, so it's the idea of a learning partner or a learning colleague. So you can have the robot set up to gradually increase in competence. Right? So the robot knows everything, yes, but it doesn't have to display everything at once. So while you are learning, the robot can start basic and start to increase in complexity. So it gives the impression that you are in a personal class with this robot, or even if it's a rehabilitation scenario where the robot is able to judge your improvements and basically add complexity to the motion, or even add weights or recommend how you can improve your range of motion by doing certain exercises. So it's all about the ability to perceive and to adapt to the environment.
And with these two particular robots that we're discussing, the Thamu, the tabla playing robot, and the cricket bowling machine, are there any plans to commercialize these devices?
Well, yes, I would say yes, there are plans to commercialize this machine, but it would have to be done in a different manner in terms of the machine in its current state. It's pretty, it's mechanical in nature, right? It's spring actuated. So it'll have to be a bit of redone in terms of maybe the use of motors, in terms of the actuation systems and all that. So it may have to be redone a bit, but yes, it has commercial value.
And what about the tabla playing robot?
The idea was to commercialize it at one point. I mean, we have to look at the intellectual property involved in it.
Sure.
So we have thought about filing patents, but the idea kind of went over because we published some of the material. But now we're looking more at the AI applications within the robots to see how we can commercialize some of those methods that we've integrated right now, and even some of the other capabilities that we want to add to the robot. So I can't speak too much about what we are going towards in case we threaten the patents again.
That's fair enough.
Yes.
I appreciate that. And as Mr. Bikramdas was talking about the bowling machine and the batsman trying to interpret the hand position and the type of ball that will be bowled, on the reverse then, with the integration then of sensors attached to the batsman, aid the bowling machine then to interpret the stance of the batsman and therefore decide what to deliver?
Yes, definitely it would. There are sensors available for that purpose. There's also sensors, bat sensors available that will give you the position of the bat, right? They'll also give you the bat speed, give you an actual position of the batsman. So yes, there are sensors that would give you that information, and this information would be valuable in terms of the AI system that would eventually teach itself to actually coach the player. And yes, it will enhance the player's ability.
It will. So that whole learning process will be enhanced, not
Correct.
hampered in any way.
If I could continue, in its current state, it will enhance the batsman's ability because of the accuracy, as was mentioned before by Dr. Lawton. Because of that accuracy of the machine, the repeatability of the machine, it will enhance the batsman's ability, because playing shots in cricket is all about muscle memory, and because of that that ability to repeat the same ball over and over, it allows the batsman to play the proper shots, the correct shots, and it's, I say, is muscle memory, and it will eventually be embedded in them to play that shot. Get your foot to the pitch of the delivery, play late as possible, as the case may be.
And some of the viewers are asking, this is for the panel, what was the motivation for developing the cricket bowling machine and the Tabla playing robot?
Yeah, the motivation behind the cricket bowler machine was, at the time, there wasn't any machine for cricket that gave you the visual cue of an arm and a hand bowling ball. So there were all repurposed machines, for example, from a tennis machines. Then there were pneumatic type machines that would just shoot out the ball. And all these machines, the coaches or the operator of the machine has to signal to the batsman when the ball is coming. And that is counterintuitive in terms of when you go to actually face a real bowler, there's no one signaling when the bowler is coming to bowl. So the main motivation was to provide a life-size machine that is proportional to a human bowler that will generate the same visual cues as a human bowler. So that was the motivation.
If I could add to that,
sure.
Also to give batsmen a more realistic atmosphere in terms of when you go out there for an actual match, there's a bowler running up and delivering the ball. There's not a person standing behind a machine signaling to you, okay, it's about to deliver, you hit the ball, boom. So with this machine now, you get that realistic clearance in terms of the arm actually turning over and delivering the ball. So the batsman could see that now. And in terms of their setup for a batsman is critical, right? And if you set up in training against the normally traditional machine, you will tend to do that when you go to the match. And if you do the wrong thing in the training, you go to the match, you do the wrong thing, and you want to know why I'm not making runs, why I'm not scoring runs.
Right.
It's because you're changing something, you're doing something here, and then when you go to the match, you're doing something different.
Right.
So with this machine, you're actually doing exactly what you would do in a match. Good.
Well, on the Tabla side of things, I mean, as Mr. Maraj had mentioned before, the Tabla is a very necessary instrument for all aspects of music, because that rhythmic accompaniment is necessary for singers and all other types of instrumentalists, right? But so we started off with the intention of it being able to accompany a singer so that they could practice, and then we found out we could incorporate it into an entire orchestra, and then after that we found that this project keeps growing in terms of potential, so that now we are looking at the education aspect of it. That's what Mr. Maraj is specifically looking at. So the whole range of research involved with this robot and robots in music in general is very young. So there's a lot of potential for research. A lot is still not properly understood, and there's a big way to push the technology still in terms of development. I don't know if you want to add anything.
Yeah, to add to it also, I think it should be noted at this point that the tabla as an instrument has its own language behind it, and that language is has been successfully being able to be reproduced and in terms of the fingers of that particular robot currently, and the language is there to assist in the entire process of carrying forward that tabla education per person based on how far they would like to carry it, because a tabla can be studied currently in terms of a full degree. You can have a master's in tabla, you can even have a PhD in tabla from many universities, not only in India but across the world as well. So I think that it is important to know that the whole language and the system and the various steps that can be taken in that one instrument is huge.
And just shifting to the bowling machine once again, Mr. Vikramdas. So the viewers are particularly interested, and we have a question. Could another degree of motion be added to the bowling machine to simulate spinning?
Yes, it could, but we had done some work actually on the hand itself. So to get that is all about rotation of the wrist, right? To get that spin motion. So I had done some work initially on actually redesigning the hand so that you have an actuator in the wrist to actually tune the wrist to get that spin motion. But currently there is the 3-wheel machine that actually you set the ball in a particular way actually, and you can get that spin motion.
Right.
Also in the normal machine you can do it, the two-way machine you can do it.
Right. Good. And as we are talking about robotics in the Department of Manufacturing Engineering, Design and Manufacturing, could you share with us then, Dr. Bisnath or panel, what are some of the other projects that we have going on in the Design and Manufacturing Engineering unit with regards to robotics, artificial intelligence, mechatronics?
Sure. So this department, design and manufacturing, was heavily structured around mechatronics to support manufacturing, and we were one of the first that pushed the concepts such as 3D printing into the local industry, so that we have companies set up for 3D printing now. Our students, in a big way, are very interested in robotics. So we have our students generally doing projects such as being able to collect litter. We have robots that climb trees, robots that are into harvesting fruit and supporting the agricultural industry. We are applying AI techniques, for instance, to agriculture and irrigation in a big way. So we know that water scarcity is a big challenge going forward with increasing population and limited resources. I mean, we are constantly reminded by WASA that our reservoirs are low, so water shortage is an important issue that we deal with. So the application of AI and controls and modeling for some of these challenges that we face locally is one of the things that we do in the department. And we try to couple robotics where it's necessary to achieve an efficient solution. So it's not just technology for the sake of it. We try to have local applications or cultural applications, or culturally specific applications to the country that are relevant to our students and the society.
Good. Excellent. Mr. Wakandas, anything you'd like to add in terms of our robotics AI drive-in DME?
Yeah, first, Dr. Bestard mentioned we had started this drive for mechatronics. We had started the mechatronics group out of this department headed by Professor Prakash Prasad, and we were really directed towards using mechatronics and robotics to aid not only the agriculture, for irrigation and all these other things, but in all aspects. We try our best to see if we can aid. For instance, we had some students actually doing some projects on sorting, doing color sorting, right, using mechatronics to color sort. So it's we have the students that have the capability and they are willing to do these sort of projects in mechatronics and robotics.
Good. So we have a lot of exciting work that's going on in the Department of Design and Manufacturing Engineering here at UTP. And gentlemen, we just have a couple minutes left, so I will just ask you if you have any closing remarks for the public on the potential, on our topic, the potential for robotics in culture and sports. So maybe I'll start with Mr. Maraj.
Yes, as I had mentioned earlier, sports and culture, I believe, is something that is integral not only for our society, but in any society, more or less, when we look at it, because the world as a whole has gotten smaller in terms of because of technology, etc. But more than that, I would like to say that in my own capacity, I look forward to having the two Tabla robot being developed even more, as well as later on in the future, something also that may go along the lines of something with the steel pan.
So therefore, as your closing comments, from the Tabla we should look at the steel pan as the next instrument.
I believe, that's something that...
And after the steel pan, do you have a suggestion? For another instrument that we should look at?
Yeah, another instrument, there are quite a lot of them, but maybe we might be able to look at a string instrument at that point, because drumming and the striking one, so a string might fall.
Okay, great. Thank you, Mr. Maraj. So, Dr. Lautan, any closing comments?
Yeah, for me, my closing remarks would be along the lines of what can these existing technologies be utilized in sports and agriculture? How can it be applied to other avenues? And I think we have seen world wars and space race have given birth to a lot of technology, and I think competition, sports as a is very competitive. The drive towards trying to develop these robots to improve athletes, the these technologies can be translated, for example, work in prosthetics. Tumors are dependent on the fingers and the quick actuation of the fingers to play the drum. Those could be translated to prosthetic fingers. So I think they must at some point translate to other forms of technology where it could benefit, let's say, the broader mankind. And I think that's where, at the end, everything should lead towards.
Good. Thank you, Dr. Lautan. Dr. Bisnath?
Yeah, so piggybacking on what Dr. Lautan had said, we are in the fourth technological revolution now. So right now we are in a space where technology is being democratized, so that you can go on eBay, you can go on Amazon, and you can buy a microcontroller for $25 US. You can buy actuators, you can buy motors, and you can go on YouTube and you can learn how to use all of these things. You can make an entire robot without coming to a university. 12-year-old child, even younger probably, can start in this area of robotics. So while we are here within UTT, it shouldn't be conveyed that robotics is this high technology area that the average person is apart from, or it's inaccessible to the average individual, especially to the young people coming up now that are constantly exposed to technology. They should be running towards things like robotics and artificial intelligence because it is their future, and they should understand it and try to get into the field now and make the most of it.
Right, thank you, Dr. Bisnath. Mr. Vikram Das?
Yeah, just to add to what Dr. Bisnath was saying, from a young age now we see kids getting involved with robotics, programming, as Dr. Bisnath mentioned. You can get these things on eBay pretty cheap, but with the Lego Mindstorm, it's evolving so fast that the kids at a very young age, they're able to program, they're able to control a robot, make a robot do something, and it brings them joy to know that they can do that. So robotics is here to help us, to work with us, to bring joy to kids, as we see, even the adults in terms of culture, right? It brings joy to people as the Tabla robot is playing. So it's really for us to utilize it as best as possible to enhance areas, not just sports and culture, but enhance all aspects now in such a way that it would just make everything a better place. As was mentioned before by our panelists, robotics is here to stay. It's not going to change. And just to add in terms of the cricketing aspect, as I'm involved in, robotics is playing a huge part in cricket at the moment. Technology on the whole. And with this, in terms of robotics, with bowling machine, it will enhance the cricketers, will make the cricketers even better than they are currently. So it's here to stay, and it's here to work with us, to guide us, and to make us better.
Good. Well, gentlemen, we are just about out of time. So I want to thank everyone for your valuable contributions and for making this webinar most informative and interesting, and a huge success. We were able to inform the population about the potential for robotics in culture and the arts. So that brings us to the end of our webinar for this evening. I want to thank the panelists for being here. We want to thank the Design and Manufacturing Engineering Unit for hosting this webinar. And please keep posted and tuned to see other webinars that are coming up throughout the month of August into September. So as the panelists have said, robotics, it's here to stay. It is alive and well, and it is definitely flourishing at the Department of Design and Manufacturing here at UTT. To you, our live viewers, I want to say thank you for streaming, thank you for joining in. And for anyone who would like to get more information, we have the website posted. Feel free to contact any one of the researchers via our UTT webpage under the Design and Manufacturing tab. Thank you very much, everyone. Do have a pleasant evening.